हेलो एवरीवन। तो आज हम पढ़ने वाले हैं फ्यूरियर ट्रांसफॉर्मेशन। ओके, सो वी हैव स्टडीड लाप्लास ट्रांसफॉर्मेशन, नाउ विल गो टुवर्ड्स फ्यूरियर ट्रांसफॉर्मेशन। Now Fourier integral formula, we know what is Fourier integral formula. Fourier integral formula for if function is f of x, then how will we determine its Fourier integral? 1 over pi 0 to infinity, then minus infinity to plus infinity, f of t, function of t, and cos ut minus x, and du dt. This is the Fourier integral formula. Now Fourier sine integral formula, 2 over pi 0 to infinity f of t sin ut and sin ux du dt, and we can do integration separately also with respect to t and x. Similarly, cosine integral formula, 2 over pi 0 to infinity f of t cos ut and cos ux. यहाँ sin ut sin ux, cos ut cos ux, and we can also determine integral separately. For a complete integral formula, this is important, we have to remember that f of x equal to, यहाँ 2 और पाई था लेकिन यहाँ 1/2 पाई माइनस इन्फिनिटी टू प्लस इन्फिनिटी ई रेज टू पावर माइनस आयोटा यू एक्स डी यू माइनस इन्फिनिटी टू प्लस इन्फिनिटी एफ ऑफ टी ई आयोटा यू टी डी टी. Okay, function of dt comes only once, whereas e raised to the power minus iota ux here and e raised to the power iota ut here. Now we have to remember some useful integral formulas like sin ax by x is pi by 2, in the limit of 0 to infinity. Sin ax by x equal to pi by 2, and 0 to infinity e raised to the power minus x square dx equal to under pi by 2. Similarly, sin mx minus infinity to plus infinity by x minus b का whole square plus a square dx equal to pi by a. Okay, pi by a e raised to the power minus a and m multiplied with sin bm. Okay, now f of s, f of s equal to function of Fourier transformation of f of x will be 1/2 pi minus infinity plus infinity f of x e raised to the power iota sx dx. Okay, so f of x equal to f inverse f of s 1/2 pi minus infinity to plus infinity f of s e raised to the power minus iota sx and ds. Okay, this is Fourier transform and this is inverse Fourier transformation. Okay, here e raised to the power iota sx and here e raised to the power minus iota sx ds. So Fourier sine transform, what will be Fourier sine transform? We have to remember it. Under 2 upon pi f of x sin sx dx, under 2 by pi 0 to infinity f of x sin sx dx. What will be inverse? Simply change the variables, all things will be same, only variable change will be there. So in simple Fourier sine transformation, we are doing with respect to x, which is our function, but in inverse sine transformation we will do integration with respect to ds, and here function of s, which is sine transformation. Now Fourier cosine transformation, 2 upon pi 0 to infinity f of x cos x dx, and inverse same, only variable change will be there. So Fourier transformation of this function, and function is 1 and 0 in modus x. 1 is when mod of x is less than a, and what is mod of x less than a represent, this function lies between minus a to plus a, and what is greater than a represented apart from this value when function is less than a, minus a, and greater than a. Okay, so always remember, this is very important. Mod of x less than a represent when a variable has the value between minus that constant to plus that constant, and mod of x represent other than those values, like here minus a to plus a, and mod of a greater than a, mod of x greater than a. What does it represent? It represent the values of x for which x is less than minus a and x is greater than a. Okay, now functions Fourier transformation, as we have studied, 1/2 pi minus infinite to plus infinite f of x e raised to the power iota sx dx. So simply put, the value of function is 1 and limit is minus a to plus a. So when you solve it, e raised to the power iota theta, e raised to the power iota theta minus e raised to the power minus iota divided by 2 iota theta. So what is this? Sin as by s. Okay. Simply another question. So put in the formula e raised to the power minus ax square. So we have this. Now it will be very useful for us if we convert this into square of something. So in order to do square of something, what will you do? We'll study it. So this is iota sx. So first of all consider we have to convert it to iota sx, है ना. तो 2 से मल्टीप्लाई कर दिया, 2 से डिवाइड कर दिया. Now we know that 2ab must be there. So 2 or under root ax is there. Now we have to calculate some value for b. So we are using under root a. From where under root a comes? If we are multiplying x with under root a, then we have to divide under root a also. So we are left with 2 is iota by 2 under root a under root ax. Now square this term, under root x square ax simply. Okay, and square of this term will be this iota sx and 2ab. 2ab करेंगे तो 2 under root ax is iota by 2 under root a. Simply this term will be get. And when square of the right term, what we will have? We will have s square by 4 under root a. So we have plus s square by 4 under root a. So we will use e raised to the power minus s upon 4 under root a. ये प्लस में आ रहा है तो इतना का इतना ही अपन माइनस कर रहे हैं. वी आर substituting the same amount we are getting from the expansion of the bracket. So we have this here. Always remember this, है ना, बहुत बार काम आता है. Many times it will be useful for us in solving the complex integration for functions. So e raised to minus a square by 4 बाहर आ जाएगा and we will take it as a new variable y. So after solving we'll get this, and we have studied the formula of this integration here. E raised to the minus square dx under pi by 2. So e raised to the power minus y square dy equal to under pi by a. After solving we'll get this. We can directly remember it also, that e Fourier transformation of e raised to the power minus ax square is e raised to the power minus square by 4 upon under root 2a. Next function is 1 by x. So simply put 1 by x sin x dx. So function is sin x by x, and we have calculated the values of this integration on pi by 2. So under pi by 2 will be our final answer. Now function is e raised to the power minus ax. So Fourier transformation of this function will be e raised to the power minus x and s dx, and we know the formula of this function, s upon s square by a square. And if same cos function will be there, cos Fourier transformation, so cos x, here we'll get a by s square plus a square. Always try to differentiate between the Laplace transformation and Fourier transformation. Now properties of Fourier transformation. Simply it is linear, same as Laplace. Change of scale property, this is for function and this is for Fourier. So f of fx equal to 1 by a f s by a. x n f of x m minus iota की पावर n t n by t s n f of s. वहाँ क्या था, -1 की पावर n था, बाकी सेम था, है ना. शिफ्टिंग अगर e आया है तो वहाँ 1 बाई एस माइनस ए था, यहाँ पे क्या हो रहा है, ये था वहाँ पे 1 बाई एस माइनस ए. यहाँ पे सिंपली फंक्शन में एस माइनस ए पुट कर देना है ना. कौन सा फंक्शन, वही जो अपने गिवन है एफ ऑफ एस वाला. नाउ मॉड्यूलेशन थ्योरम. If we have f of x cos x, then 1 by 2 f of s plus m plus f of s minus a. And if his derivative is there, then minus iota s f of s if function is 0 and x tends to plus minus infinity. And if function's nth derivative will be 0, then minus iota s as n f of s. So a2x f of x dx will be f of s upon minus iota s. Now correlation theorem, if your function like this f of u gx minus u du, and it will be vice versa true, inversion also true है ना. सिंपली जो ही कर रहे हैं अपन एस और एक्स में. नाउ पर पार्ट्स आइडेंटिटी क्या है ये देखो जरा. एफ ऑफ एस जी बार एस टी एस विल बी इक्वल टू माइनस इन्फाइनाइट स्पेस बाय टी एफ ऑफ एस जी एक्स बार डी एक्स, वेयर एफ ऑफ एस इज Fourier transformation of function of x and g of s Fourier transformation of function of gx, and gx and gs are complex conjugate of gx and gs. So minus infinity plus infinity f of square d is equal to fx square dx. It is called partial identity. And relation between Laplace and Fourier transformation of function of t equal to 1 upon under 2 by Laplace transformation of gt. Remember this. So this was the Fourier transformation. Thank you very much.